Whoops. Okay. Come on. Steady now. That's right. So we're going to have a look at here circular motion.
Okay.
Again, we haven't really looked at it yet. Okay, circular motion, please. How's my battery doing, actually? I'm okay. You write this title down? Circular motion. So circular is the adjective of circle. So this lesson is all about motion in a circle. Okay? Can I go on?
Yeah.
Yes? Right. Oops. Look, it's a circle. But I do need to give you some vocabulary. So you see this area we call the angle, theta, or we call the radius, and S we call the arc length. Yeah. So please make notes of these words here. That is one big circle. Yeah, now you see, that would be in math class, you see. In physics we use S because if we think of something moving in a circle, we use S for distance travelled. Yeah. No, I'm not saying some places don't use L. I'm just saying we would use S or X. I wouldn't really be using L. Okay, do you have those words, maybe? Yeah. No, S is just this purple part. Okay, you got that? Yeah, alright. So in physics, when we're dealing with motion in a circle, we don't use degrees. We use a new unit known as the radian. So you know previously in maths class, you would be using things like this. Degrees. Yep. And even in physics we use degrees. But for this lesson, we don't use degrees, we use something new called a radian. So the radian is defined as follows. 1 radian is 57.3 degrees. That's what 1 radian is. 1 radian is 57.3 degrees. Yeah? Now, why this is important will be explained in math class. Your math teacher will explain why it's important. And if you are wondering where the 57.3 came from, in fact 57.3 is exactly 180 divided by pi. For physics, it is important because the formulas we use in physics only work when we use radians. Now look, you don't need to write all this. What you really need is this definition here. 1 radian is 57.3 degrees. So radians are pretty big angles. 1 radian is like this big. Pretty big, okay? Right. Have you got that number? 57.3 is a radian. Okay, let's go on. Whoops, that's not it. Come on. There we go. So let's have a look at an example first. let's convert 30 degrees into radians and 0.25 radians into degrees. So let's have a look at this. Example, 30 degrees equals 30 and degree. How big is 1 degree? Well, if you remember here, 1 radiant, how big is 1 radiant? 57.3 degrees. So if you want, you can say 1 over 57.3 radians equals 1 degree. Yeah, can you see what I did there? So I can put that in here and say that's 31 over 57.3 radians. Okay, so what is that? 0.524 radians. Okay, in the next example, I ask you to convert 0.25 radians, isn't it? Actually, this one I should have done first, it's easier. How big is a radiant? 57.3 degrees. So this equals what?
57.3 into 14.325
degrees.
Yeah.
So we're just using a new unit here, radians instead of degrees. That's all. There's nothing special here yet. Okay, back to the slides. Yeah. We've seen 2 types of motion so far in physics. SUVAT in 1 dimension, and then SUVAT in 2 dimensions. Remember the projectiles? Yeah? We're going to look at motion in 2 dimensions, but this time motion in a circle. So for example, we have seen this type of motion, you know, like a car. Horizontal, and we've seen this type of motion. So now what we're going to look at is this type of motion, which can be vertical or it can be horizontal. Okay, it can happen on the ground or up like this. Right. Let's see what we have next. Okay, so what makes something go in a circle? If something is moving in a circle, then there's a force acting on it, of course. And the force is perpendicular to the velocity and directed towards the center. Now you need to write that down, but you can write it in a minute. Let me just draw it first. So if something is moving in a circle, the velocity is this way, and the force is this way. And please, this force always points towards the center of the circle, and the velocity and the force are always perpendicular. Okay, so if something is moving in a circle, this must be true. If something is going around in a circle at its constant speed, it must be because the force is going towards the center. And the best way to think about this is if you think about a child, and the child has a rope, and he's swinging the rope around. The force is always to the center of the rope, where its hand is. You're swinging something around. Okay? The force always goes towards the center. This definition has been asked in the exam, so please write it down carefully, the definition.
So this definition of what?
This basically, in the exam they might say, what causes circular motion? So yes. Okay. Got this? Yeah. Can I go on? Yeah? Okay. So I already drew it for you. Okay. Now you don't need to write this down. It's not really a definition, it's more just vocabulary. So, how badly do you need these? I can swing them around. Have we got something actually? Oh yeah, whatever, something like this. So when I'm swinging this around, going round and around, the force is always going towards the center, where my hand is. Okay? So the force is always going towards the center. Yeah? We call this force centripetal force. Now you can still just call it force. It's still just force. But if you want the person to know that this force is going towards the center, we can call it centripetal force. So did you draw a picture of the circle that I drew? No. So what you can just write here, you can draw this, and the name of that force is centripetal force. Okay, so first draw this circle. C and F. Okay, and here is the spelling. No, not yet. No, you don't need to draw the man, just a circle.
Centripetal.
Yeah, well, I'm going to put it back now.
Just
Wait.
centum or something?
Centripetal. Well, I'll put it back. Can I go back?
Yeah.
So, the name of that force is centripetal or centripetal force, depending on how you pronounce it. Yeah, so I just need the name from you, okay? Centripetal or centripetal. That's what I thought.
In some you have a second name of the potato.
Petal?
Potato.
I did.
No, they say potato.
Who does?
Is it?
That's petal. Oh.
The force contributes to killing.
Huh? No, this is just vocabulary. All you need to know is centripetal force is the force towards the center. What is Newton's second law? F equals ma. So F is a vector, true? Yeah. If m is 1, then what can we say F is? F equals a. Okay. So what I'm trying to get you to think is, whenever you have an F, you also have an A. And the A and the F always point together. So when this is moving in a circle, the F points to the center, and also the A acceleration points to the center. Because F and A, they point together. Because remember, F equals ma. So you have also, this should not surprise you, you have centripetal acceleration, which is the acceleration that points towards the center. So you don't even need to write this down. What's the key word here in both centripetal? So what do you think centripetal means? Towards the center.
Yes.
You don't need to write that. It's okay. I don't want you writing too much. You're writing centripetal acceleration, yeah. So centripetal means basically towards the center. Yeah. Okay. Right, so now this definition. We have something called angular velocity. Angular velocity is how quick the angle changes, and the units are radians per second. what units do we measure speed in? Meters per second. So we measure angle speed in radians per second. Got it? That angular velocity, that is not a W. That's a Greek letter. Does anyone know this Greek letter?
No.
Yeah, you know, KJ, what is it? No? Nobody knows this Greek letter? I'll give you a clue. It's the last Greek letter. Omega.
Yeah.
So,
Omega.
the angular velocity omega is how quickly the angle changes. Okay?
It's in knot, right?
Huh?
I don't just say it's in knot.
Which?
Omega.
I don't think you ever used that letter in maths.
No, not here.
Yeah, no, there are some topics in maths with it, but not for us, I think. So look, for example, 1 radian per second. How big is 1 radian? 57 degrees, right? So if I say 1 radian per second, that means per second it moves 1 radian. So 1 radian per second would be like about this speed. About 57 degrees in 1 second. Okay? So that's 1 radian per second. Per second. Okay. Yeah, actually, this here. This is for later. That's. Actually, this should. Sorry, this here should be on the next page. Okay. So. This definition here is not related to the previous. This is something new. You see this unit per second? Per second we often call a hertz. It's the same thing. Okay? So if you see 1 H cell, it's the same as 1 per second.
Well, that's in waves.
Huh?
Use the same as in waves.
It's the same as the one in waves, correct, yeah. This should be on the next slide. So I'll just write 1 hertz equals 1 per second. Yeah, 1 hertz equals 1 per second. Did you write that? Yeah. You don't need to write the whole sentence. 1 hertz equals 1 per second. Okay. Now, something next. The periodic time is the time taken for 1 orbit. So, that big T is how long it takes for 1 orbit. That's called the periodic time. So what unit is it? Seconds, just. Of course, the unit is seconds. It's time. If T equals 2, then it takes 2 seconds. So it'll be like this fast. 1, 2.
Did I write this?
Oops, sorry. Just even periodic time equals time for 1 loop.
Well, 1 loop?
Yeah, 1 orbit. 1 loop. So you actually did the ESAT lesson with Joan on circles. So you know there's lots of vocabulary here. Revolution, rotation, orbit. Yeah. So I just picked orbit, but you have other words you can use. Loop, revolution, rotation, circle, what? Right, next. The frequency f is the number of orbits in 1 second, and the units are per second. So for and now, This is where we can use our new unit. So if I say f equals 2, that means 1 second, it can go twice. Okay, I'll say it again. If f is 2, it means in 1 second, it can go twice. Okay, so that's what I mean by f here. What about if f is 0.5? It only goes half in 1 second.
So f is equal to 1/2.
Yes, we'll get to those in a moment, yeah. Okay, got that? The definition? Yes? You don't need to write this example down if you understand this, yeah? Yeah. Can I go on?
Yep.
Yeah, okay. Alright, so now, if you remember, for the SUVAT we had 4 equations. We had S equals U plus V over 2 times T, V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. We can't use those formulas here. Those formulas are only for this motion. We need new formulas now for circular motion. So here are the new formulas for this motion. Our first formula is that T equals 1 over F. The first formula. Or the other way around is true, F equals 1 over T. So this is formula 1.
And T enough to take up to 1?
Huh?
T enough to
So write this down. I just gave you the definition 1 minute ago. T is the periodic time. Yeah. Yes? Did you write it down? Yep. Okay, that's the first formula. The second formula, omega equals 2 pi over T.
What's the again?
You know what it is. Angular velocity. You remember? Formula number 3. The velocity equals omega or. And then the last formula is to calculate the acceleration.
Omega R.
Yeah, acceleration is v squared over or.
R is radius.
Or is radius.
Acceleration.
So these are our 4 formulas. Yeah? Did you get them? You have them? So I think we probably need to look at some examples now. Yes? So, does anybody know what RPM means? You know it? RPM?
Yes, around 5
Huh?
Revolution per minute.
Almost. Yeah, revolutions per minute, yeah. Rotations per minute. So what I'm saying here is the CD is turning 500 times in 1 minute. What is the omega? Okay, so write that down and then we'll do it. Okay, so let's draw this. So what you have is, you have your CD, and it's spinning 500 times per minute. So, Fahad, can you do 500 divided by 60?
8.3.
What is it?
8.3.
So that's 8.3 per second. So what is the 8.3? Is that F? Is it T? I mean, what is it? Yeah, you're saying here that F equals 8.3 per second. That F equals 8.3 hertz. Because in 1 second it turns 8.3 times.
I dig it.
What part?
Next.
This I give you.
10 minutes, okay?
This I give you, yeah?
Like,
This here I get by dividing by 60 to make it per second.
okay.
And this is what F is this. F is how many per second.
Okay.
I'm not finished. I want to find omega. So, what formula could I use?
2pi over t.
Yeah. So first I need to get T. So T equals 1 over F. What's that? What is it?
0.1.
Seconds. And then finally we can use, what one did you say, Amanda?
Omega?
Omega equals 2 pi over
t.
T. So then that means then you have omega equals 2 pi over 0.12. What's that? 2 times 3.1415 over 0.12. What is it?
523.
Yeah.
523 points.
52?
520. 523 points.
You typed it in wrong. What is it, Amanda?
52.3
52.3.
Oh, okay.
3 pi.
Okay, 52.4 radians per second. Did you write that down? Okay. Can I do the next example? Yeah, okay. So, now I'll draw this. A car takes 5 seconds to go around a roundabout of 6 meters. How fast is the car traveling? Okay, so I'll draw this for you. This is a roundabout, and here's the 6 meters, and the car drives around it. Well, okay, we'll put it closer. You know a roundabout? I'll draw it for you.
On the road.
On the road. So what happens is the car comes along. No, we drive on the left, so the car will come this way, and then the car will drive around. So let's imagine the car goes around once for fun. Yeah?
I did that for 5-6 times.
So the car goes around the roundabout. Yes? And how long does it take to go around? I think I said 5 seconds. So it's going kind of fast. Okay. Right, so we know that R equals 6, T equals 5. So, in fact, actually, I should be a bit clearer. That's actually big T. Okay, so then F, how fast is the car going? F equals 1 over T, so that means F equals 0.2. omega equals 2 pi over t. So what does the omega equal? Can someone tell me 2 pi, 31, is it? 2, 10, 31.4?
1.256.
Oh, sorry, 1.26 radians per second. So finally we can get our answer. Remember we have the formula V equals omega or. So V equals 1.26 times 6. What's that? 7.5. So that's how fast the car is going. The car is going at 7.5 meters per second. Yep. Okay. Can I go to the next example? Yep. So a 10,000 kilogram plane flies in a 1 kilometer circle in 1 minute. So I'll draw that for you. Here's my plane. Yep, that's it. And it flies in a circle. Okay. And this circle here is 1 kilometer. And I tell you its mass is 10,000 and the time is 1 minute. So that means the time is 60 seconds. So that means the F, which is 1 over T, is 1 over 60. What's that, please?
0.016.
67
Yeah.
hertz. Okay. The omega is 2 pi over T. So what's the omega here? 2 pi over 60, please.
0.105.
Radians a second. And finally, well not finally, the V equals omega or. What's that? Omega multiplied. Now the or, be careful, the or is 1,000 meters. So what is 1,000? Well, it's just going to be 105 meters per second. But that's not what I want to know. I want to know how much force is coming from the engines to make the plane turn. So I want to know what is the F here. Okay. What is my formula for A? What's the formula for acceleration? What is it? I gave it to you. What's the formula for A?
B half squared.
B squared over 4. So that is 105 squared over 1,000. What's that?
Oh my God.
Yeah.
11.025.
Yeah, 11.05. 11.
Okay, let's go to 11. 11 meters per second squared. So you're nearly finished. You can say F equals MA. So F equals, so look, here is, oh sorry, that should be a square. Here is the A, and then, where's my M? Here is my M.
What's the unit?
10,000.
It's
So it would be 11, 1, 2, 3, 4 zeros, yeah. So that's newtons. So let me see, that is 110 kilonewtons is the force. So really, all we need for this lesson is our 4 new formulas and Newton's second formula, F equals ma. Okay.
No.
No, more examples.
More examples.
Yeah.
Tell me the three.
What is the Yeah, not yet. Don't worry. And anyway, I don't think anybody's going to go to the first math class, are they?
No.
No.
Banking?
You want it? Huh?
Oh, sir. Right.
Banking, sorry, yes. I was distracted. Banking just means when the plane turns to go in a circle. So like the plane goes like this, and then it turns so it can...
Oh, that's banking.
That's banking.
Yeah.
And also banking means go to the bank. But that's not what I mean here. Okay. A plane is banking. Actually, sorry, I did this one already. Yeah, I did this question in 2 parts. Did I? No, sorry, this one I did. Oh yeah, so this is the next one. Yeah, okay, so I'll draw this one. So what you have is our boy, and he is swinging around a big rope. So this is going around and around. And I tell you it is 1 kilogram, 2 and 2. Okay, so this is 1 kilogram. And the radius is 2 meters and it's 2 hertz. Okay, so this is 2 meters. And the frequency is 2 hertz. So that means in 1 second, how many times? 2 times. So my question is, how fast is it moving? Okay, so that's okay actually. We can say again that T is 1 over F, which will be 0.5 seconds. Omega is 2 pi over T, so what's that please?
12.6.
12.6 radians a second. So finally V, which is omega or, is 12.6 times 2, so what's that? 25.1, whatever, meters per second. So this ball is moving at 25.1 meters per second. Yeah? Okay, next now. One more example. 5, 4, okay. So in this last example, what you have is you have a big sphere. It's a big ball. And inside of it there's a ball rolling around on the inside of it. Yeah, inside of this big ball. And I tell you that this radius of the big sphere is 5 meters. And then on this smaller circle inside of it, this is 4 meters.
So is this how water?
Huh? So picture a big ball, and inside the ball there's a smaller ball rolling around.
Okay.
Like inside a bowl. Can you picture that? Yeah? So here there's a force going towards the center, which I call F. So let me draw the picture here. Oh my goodness. Can I go down a little bit? Yeah. So if you look at it like this, from the side, this here is 5. This here is 5. This here is 4. How big is this here? 5. it's also the radius. So how big is this piece? This piece here is true. Because we're using Pythagoras. So I can know this angle here, phi, is tan inverse 3 over 4. What's that, please? What's the angle, please? What is it?
36.9.
36.9 degrees. Now, when this is in contact with the table, there is a reaction force this way, yes? How fast is the ball moving? The speed. Okay, so look, there are two forces here. That's 36.9, okay? There's one force going this way, which I'll call it or, and then there's another force going down this way, which I call mg. We should break this force up into a part this way and a part this way. This piece here will be or cos phi, and this piece here will be or sine phi. Now, is the ball moving up or down? No, it's only moving left and right. So the ball is only going like this. So that means we can say or sine, one second, oh no! How did I fix this last time?
It's okay, you can imagine.
It's okay? I don't know how to fix it. I pressed something.
Control.
Maybe? It doesn't matter. You can still read it. This is weird. Okay, so this force here should equal this force here. So I can say or sine phi should equal mg.
Up and go down.
Yeah. This force here, or cos phi, this force here, what does it equal? Well, what is this force doing? This or cos. What's the or cos doing? Yeah. It's making it move in a circle. Yeah, it's going to the right. It's making it move in a circle. So what you can say is, okay, this is the force that makes it move in a circle. But Newton said that F equals ma. But we have a formula for A. What's our formula for A? It is V squared over or. But what's the or? It's 4. So we have this formula and we have this formula. Sorry, I lost my end, thank you. So what I can do here is I can say or equals mg over sine 36.9, true? And put it in here. So now I have mg cos 36.9 over sine 36.9 equals mv squared over 4, which is great, because now I can get my v. So v equals square root 4g cos 36.9 over sine 36.9. So what's the v equal? Sorry about this image being weird. That doesn't matter. It's too late now. Alright, what did you get here? What did you get? Come on. This is the last question, so I'm so sorry that the image turned. It looks so weird. What is the answer here?
Are you supposed to use the big one?
The radius is the radius of the circle that's moving in. So in that case, it's the 4 on the diagram.
Four.
Yeah, 7.23. So the answer is 7.23 meters per second. That's how fast the little ball is moving. Okay? Yeah. This one's a little bit difficult. In fact, this one is maybe just a little bit more difficult than what you get in the exam. But only a little bit more difficult, okay? In the exam it will be very close to this. But maybe in the exam they make it a little easier because they give you the picture. That's all. But really this is kind of like what you get in the exam. But not more difficult than this. This is like the most difficult. Okay? Right, so if I go back here. Yeah. So I'll put these up on Moodle. Now I'm thinking, because I have 2 topics to do on Friday, if I don't have time to do this in class on Friday, I might just record the video again in the office and upload it.
It's okay.
Yeah? But we'll try. Okay. So don't forget now,